Hi students, what is our 10th question in short questions? Show that every positive integer is of the form 4q plus 1 or 4q plus 3 for some integer q. First you should know even integer and odd integer. Even numbers are 2, 4, 6, 8 like this, and odd numbers are 1, 3, 5, 7 like this. To solve this problem, you should understand Euclid's division lemma. What is Euclid's division lemma? For any positive integers a and b, there exists a unique whole numbers q and r such that a is equal to bq plus r, where r is greater than or equal to 0 and less than b. B means this is divisor. This is remainder. This is dividend, divisor and quotient plus remainder. If you divide a with divisor b, these two are positive integers and you will get a remainder r, and quotient is in the form of q. Dividend is equal to divisor into quotient plus remainder. This is dividend is equal to divisor into quotient plus remainder. This remainder must be greater than or equal to 0 and less than the divisor. Show that every positive integer is of the form 4q plus 1 or 4q plus 3 for some integer q. Let a be a positive integer. I am dividing a with divisor 4. Here I am taking a as dividend. What is dividend here? A. I am dividing dividend a with 4. What is the quotient you are getting? Q. And remainder r. This r must be, r should be greater than or equal to 0 and less than 4, because you are dividing a with 4. You know dividend is equal to divisor into quotient plus remainder. A is equal to 4 into q plus what is the remainder? R. This r must be greater than or equal to 0 and less than b. You see, r is greater than 0 and less than the divisor. Here also r is greater than or equal to 0 less than the divisor. Divisor is here b, divisor. Now you know a is equal to 4q plus r. This r must be greater than or equal to 0 and less than the divisor. Now we have to take r is equal to 0, r is equal to 1, r is equal to 2, r is equal to 3, r is equal to up to 3 you have to take. You should not take 4 because remainder must be greater than 0 and less than the divisor. Less than the divisor means less than 4. You have to take up to 3. If r is equal to 0, then a is equal to 4q plus 0. A is equal to 4q. We have to take r is equal to 0 and r should be less than divisor 4, means up to 3 you have to take. Now r is equal to 0 I have taken. Now r is equal to 1, then a is equal to 4q plus r is equal to 1 you have to take. Substitute r is equal to 1. You are getting a is equal to 4q plus 1. Here a is equal to, you are getting 4q. Next you have to take, next you take r is equal to 2. Then a is equal to, substitute in this one. A is equal to 4q plus r. R is equal to 2 you have to take. 4q plus 2 you have to take. You are getting 4q plus 2. This is an even number. This is odd and this is also even. Now if r is equal to 3, then substitute r is equal to 3 in this equation. Because you are dividing a with 4 divisor, you are getting the remainder r and quotient is q. Now a is equal to 4q plus what is r here? 3. 3 you have to take. Now this is an odd number. If the question is given odd positive integer, now we have to take these two. A is equal to 4q plus 1 and a is equal to 4q plus 3. Now if we take a is equal to odd integer, odd number, then a is in the form of 4q plus 1 or 4q plus 3. Now we will correct the question. Even number, we will correct it as even. We will take even. Now it becomes, let a be a even positive integer. Then question becomes 4q or 4q plus, if the question is even, a is even integer, if a is even positive integer, then a is in the form of 4q or 4q plus 2. If it is odd integer, you are getting a is in the form of 4q plus 1 or 4q plus 3. If question is even, then a is in the form of 4q or 4q plus 2. In examination, they may give odd or even. If odd, the answer is 4q plus 1 and 4q plus 3. If it is even number, it is in the form of dividend, or a is in the form of 4q or 4q plus 2. Note, this is the explanation of 10th problem with examples. Already you know Euclid's division lemma. It is if you divide dividend a with a divisor b, you are getting quotient q and remainder r. Always remember, remainder is always greater than or equal to 0. It is less than b, means divisor. Remainder is always less than the divisor. Now, what is our 10th problem? Every odd positive integer is of the form 4q plus 1 or 4q plus 3. Odd number, you see, 1, remainder is 1, and here also remainder is 3. They are odd numbers. Now, even positive integer is of the form 4q plus 0, means remainder is 0 there. 4q plus 0, it is equal to 4q, or it is in the form of 4q plus 2. 2 is even number, that is remainder. Now, I will take one example so that you can understand very easily. In Euclid's lemma, you are dividing a positive integer. You are dividing with a divisor b. This is also positive integer. You are getting quotient q and a remainder r. This r is always greater than or equal to 0 and less than the divisor. What is dividend here? Dividend a is equal to 4q plus 1. What is a is dividend, 4 is the divisor, q is the quotient, 1 is the remainder. You see, you are dividing in this problem, you are dividing a dividend with a divisor 4 and you are getting quotient q and the remainder is r. You see, it can be written as dividend is equal to divisor into quotient, means 4q plus remainder r. This r is greater than or equal to 0 and less than 4. Always remember, remainder is greater than or equal to 0 and less than the divisor. This remainder is always less than the divisor. Next, I will take one example. See, here dividend a is equal to 4 divisor into quotient plus remainder. This is an odd number. I will take an odd number. 13, you take. 13 is odd positive integer. 13 is odd positive integer. You divide 13 with, dividing 13 with 4 we have to take because here divisor is 4. 4 3s are 12. Means what is the remainder you are getting? 1 is the remainder. You see, you remember, it is in the form of odd number is dividend is in the form of 4 cube plus 1, whether it is true or false. This is dividend. You see 13. How can you write 13? 13 can be written as 4 into 3 into quotient plus what is the remainder here? 1 is the remainder. You see, you check whether it is in the form of 4 cube plus 1. 4 into what is q here? This is q and this is remainder. What is 3 here? Q plus what is the remainder here? 1 is the remainder. If you take a positive odd integer, it is in the form of 4q plus 1. This is the example. I will take 14. I will take here 14. It is an 14 is belong to positive integer and this is even number. If you divide a dividend a with 4, you are getting quotient q and the remainder is r. This r is greater than or equal to 0 and less than 4. Means it is should be in the form of 4q. Even number should be in the form of 4q or 4q plus 2. Let us take one example 14. It is even positive integer. I will divide because here divisor is 4. I am dividing it with 4. 4 3s are 12. You are getting what is the remainder you are getting? 4 3s are 12. You are getting remainder 2. Now 14 is equal to see 4 into 3 plus what is the remainder here? 2. We will check whether it is in the form of 4q or 4q plus 2. As a, this is dividend a, 4 into what is quotient here? 3, 4q plus you are getting the remainder 2. This is over. Now I have taken 13. You got 4q plus 1. Next I will take 15. Odd number I will take. Again I will divide. We got 4q plus 1. We did not get 4q plus 3. For that one I will take an odd number 15. I will divide it with the divisor 4 because divisor is 4 here. 4 3s are 12. I will take 4 3s are 12. You are getting 3 as the remainder. What is the quotient here? Q. And what is the divisor? B. Whether 15 is equal to dividend 15 is equal to 4 3s are 12. 4 into 3 plus you are getting the remainder 3. Whether we will check whether you are getting dividend is equal to 4q plus 3 or not. A is equal to 4. This is q. Already you know this is 3 is q plus what is the remainder? 3. We got a is equal to 4q plus 3. Take odd positive integers 13 and 15. You are getting dividend a is equal to 4q plus 1. They are in the form of 4q plus 3. Now I will take 16. 16 I will take. I got a is equal to 4q plus 2. This is over. I did not get 4q. It should be in the form of 4q, even number. Now I have taken 16 even number. I am dividing it 4. 4 4s are 16. What is the remainder you are getting? Remainder is 0. And this is q and this is b. We will check whether we are getting 4q or not. Now you see 16 is equal to 4 into 4 plus what is the remainder? 4 into 4 plus remainder is r means 0. Whether let us check whether it is in the form of 4q or not. A is equal to 4q plus what is the remainder? 0. As you got a is equal to 4q and also you got dividend. It is in the form of 4q plus 2. As here also what is the odd integer you are getting? 4q plus 1, and also you are getting a is equal to 4q plus 3. What is our next problem? 11th problem. Show that root 2 is an irrational number. We know root 2 is irrational number. Root 2, root 3, root 5, root 4 is a rational number because it can be written in the form of plus or minus 2. 2 by 1 means plus 2 by 1 minus 2 by 1. In mathematics, you have direct and indirect proofs. What is direct proof and what is indirect proof? We have to prove this through indirect proof. What is direct proof? Show that vertically opposite angles are equal. If two lines are intersecting with each other, we have to show that vertically opposite angles are equal. This is direct proof. How to prove this one? A plus B, angle A plus angle B is equal to 180. And also angle B plus angle C is also equal to 180. This is 1 and this is 2. Angle A plus angle B is equal to 180 degrees. Angle B plus angle C is equal to 180 degrees. Equating both, angle A plus angle B is equal to angle B plus angle C. Angle B cancel, and you will get angle A is equal to angle C. Angle A is equal to angle C. Vertically opposite angles are equal. This is direct proof. What is indirect proof? We know this is a rational number. We have to assume this is a rational number, and you will get a contradiction. After getting contradiction, we will say root 2 is an irrational number. We have to prove this through indirect proof. What is indirect proof? Roughly I will tell you. Root 2 is equal to, it is a rational number. First we have to take it. Root 2 is an irrational number, we know, but we have to assume to the contrary that root 2 is a rational number. Root 2 is a rational. A, B are co-primes. We have to prove A, B are not co-primes. Then you will get a contradiction. Then you will say root 2 is an irrational number. Now we have to prove A, B are not co-primes. In indirect proof, let us assume to the contrary, root 2 is a rational number. You take root 2 is equal to A by B. A, B are co-primes. It is a rational number. You take rational. A, B are co-primes. Co-primes means they will have one as common factor. HCF of A and B is 1. Co-primes means 2, 3 are co-primes. 4, 9 are co-primes. Like that, root 2 is equal to A by B. It is a rational number. Now, squaring both sides. Root 2 square means 2 is equal to A square by B square. Squaring both sides. Now you will get 2b square is equal to a square. Now we can write 2 divides implies 2 divides a square. Therefore, 2 divides a. You will have a doubt. See, 2 divides a square, then 2 divides a. Means what is the, I want to make you understand. If AB is equal to x, A divides x and also B divides x. A is the divisor of x, B is also divisor of x. And also if you want, I want to make you understand, 2 into 3 is equal to 6. You know 2 is the divisor of 6, 3 is the divisor of 6. 2 divides 6, 3 also divides 6. Why? Because if you multiply these two, you are getting 6. Like that, 2b square is equal to a square means 2 divides a square and also 2 divides a. Now we have shown 2 divides A. Now we have to show 2 divides B also. Then you will get a contradiction. 2 is dividing A and also B. But B are co-primes. If 2 divides A and also 2 divides B, A and B are not co-primes. There we will get a contradiction. Then we can say our assumption is false. Then what is given is true. You take 2b square is equal to a square. Let us take a is equal to 2c. C belongs to integer. Substituting the value of a is equal to 2c in this equation. 2b square is equal to a square means 2c whole square, implies 2b square is equal to 4c square. 4c square is equal to 2b square. Now this can be written as 2c square is equal to b square. Now you can write implies 2 divides b square. Therefore 2 divides 2 also divides b. Like that 2 is dividing a and also it is dividing b. Here 2 is the divisor. 2 is the divisor of a. Two divides a means 2 is the divisor of a. Here also 2 is the divisor of b. This is 1 and this is 2. From 1 and 2 we can conclude 2 is the divisor of a and also b. But here we have taken a, b are co-primes, means a and b will have 1 as common factor. But here 2 is the common factor for both a and b. This is contradiction. This is contradiction because 2 is the divisor of a and also b. Our assumption is false. What is our assumption? Root 2 is a rational number. But after contradiction, our assumption is false. Then what is true? Given is true, root 2. Therefore, root 2 is root 2 is an irrational root 3 is also irrational number. We can show root 3 is also irrational. Root 5 also irrational. We can show by the indirect proof. Now what is 12th problem? Show that 5 into 11 into 13 plus 13 and 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. This problem depends on fundamental theorem of arithmetic. What is fundamental theorem of arithmetic? Every composite number uniquely expressed as prime numbers, product of prime numbers. Now we have to simplify these two and we have to show these numbers are composite numbers. Now you take 5 into 11 into 13 plus 13 is equal to, you take 13 common here, 13 into 5 into 11 plus 1. You multiply 13 with this. 13 into 5 into 11, you are getting plus 13 into 1, 13. It can be written as 13 into 5 into 11, 55. 55 plus 1, 56. This can be written as 13 into 8 into 7. 8 sevens are 56. I wrote this number as product of primes. Therefore, this number is a composite number. Therefore, given number is composite number. Now take this number 6 into 5 into 4 into 3 into 2 into 1 plus 5. You take 5 common here. 5 into 6 into 4 into 3 into 2 into 1 plus 1. This can be written as 5 into 144 plus 1. 5 into 145. This can be written as 5 into 145 can be written as 5 into 29. This number, I wrote this number as product of prime numbers. Therefore, given number is a composite number.